Hello and welcome to this video. The last video we have studied the residue system or complete residue system for an integer, and in today's video we will study the reduced residue system. Okay, we start with the definition of reduced residue system. Reduced residue system. Okay, the set of integers a1, a2 up to so on ak is called a reduced residue system modulo m, written as reduced residue system mod n if the following conditions hold. The first condition is that the GCD of ai and m is equal to 1 for all i's is equal to 1, 2 up to so on k, means every ai is relatively prime to m. And the second condition is ai is not congruent to aj mod m for all I is not equal to j. And the third condition is if n is an integer relatively prime to m, then this n must be congruent to ai modulo m for a unique I, and this I is between 1 and k. So this is the definition of reduced residue system. We move further to understand this with the help of an example. The set of integers one, 5, 7 and 11 is the reduced residue system modulo 12. We can see clearly that 1, 5, 7 and 11 all are relatively prime to 12, and also they are not congruent to any of each other modulo 12. So the condition 1 and 2 are clear. Now we have to check the third one. Let a be any integer such that the GCD of a and 12 is equal to 1. Now we have to show that this a is congruent to one of the integers from this set. Okay, to verify the third condition. Alright, by division algorithm, a is congruent to r mod m, where this r is between 0 and n. Greater or equal to 0 but strictly less than m. And here, sorry, m is 12. So is strictly less than 12. Alright. Observe that the GCD of a and 12 is here, instead of this m, it is also 12. Observe that the GCD of a and 12 is 1 and a is congruent to r. This means the GCD of r and 12 is also 1. So r is between 0 and less than 12 and the GCD of r with 12 is 1. So there are some possibilities for r, and that are, thus r can be 1 of 1, 5, 7 and 11, and that is what we want to show. This means reduced residue system mod 12 is equal to 1, 5, 7 and 11. Alright, we move further. Now there is another very important definition which is called Euler's phi function. We will study this Euler phi function in detail in the coming videos. Euler is considered as one of the greatest mathematicians of all times. Okay. The definition of Euler phi function is, for each positive integer n, we define a number denoted by phi of n as phi of n is equal to 1 if n is equal to 1, and the number of positive integers less or equal to n that are coprime or relatively prime to n for n is greater than 1. So phi is here known as Euler's phi function. For example, the Euler phi function of 2 is equal to 1 because there is only one integer which is less than 2 and that is relatively prime to 2, that is 1. Similarly, Euler phi function of 3 is 2 because the number of integers which are less than 3 and are relatively prime to 3. And similarly, phi of 4 is also 2 because 1 is relatively prime to 4 and 3 is relatively prime to 4, so their total numbers are 2, and the number 2, integer 2, is not relatively prime to 4, that is. And similarly, phi of 6 is 2, phi of 7 is 6, and so on. Now there is a theorem which we will present without proof. The statement is, if a1, a2 up to so on ak form reduced residue system modulo m, then the number k is equal to Euler phi function of m. And that is all about this lecture. Lecture is interesting and understandable, then please like the video and subscribe the channel.